system theory. This is the introduction lesson about control system design. And so, I need to give some basic information. And you have already known about mechatronics, but we need to talk about it, okay? First of all, the section 1. So, what is mechatronics? Anyone knows that? For example, so what's your name? Yeah. Süreyya. Süreyya, what's mechatronics? Yeah. In terminology, mechatronic means that it's a combination of, just like the Freya said, the mechanic and electronic. Okay? But in the control system, we will mainly focus on the system dynamics for this lesson, because the system dynamics consists of what? The PDE. What's PDE? What's your name? Albara. What is PDE? Okay, so what's your name? Suda, what is PDE? Partial differential equation, right? If you want to design any system, in the system dynamics or the control system, we need to create the sum equation of motions, or the equations, with the relation of the what? To the time characteristics, right? The derivative, the integral term, must be implemented on this case. Because if you want to design the mechanical system, electronical system, or if we combine these two systems in a one form, we need to use the mathematical models, mathematical equations. Okay? And so the PDE is combining with the what? With the areas of mechanic plus electronic plus hydraulic plus etc., right? And so if we have any system in the mechanics, electronics, or the electrics, we need to write this system in terms of what? Mathematical equations. In mechatronics, we will use the system dynamics. And so if we have any system dynamic equation or the form related to some mechatronic system, and so we can control it. Okay? This is the basis of the what? The combination of the mechanic and electronic. And so, if you say the mechatronic is the combination of the mechanic and the electronic, this is not true. But for an engineer, if you are an engineer, and so you need to define the sum equation, mathematical equation, Freya, right? Okay. And so, what's the conclusion? We need to use math, right? And so, what's the result of the math for the partial differential equation or the equation of motions? What do we need to use to what? These partial differential equations. We need to obtain something, but what? No, it's not the transfer function. If we design or run any system in system dynamics or the mechatronic systems, we will get what? The some responses, time responses, right? If you push this button, just like this one, and so this position is changed. X0, X cube, right? And so this is the result of the time response of this system. It's a mechanical system. And so we can move it or back it, right? What's your name? Amjad. I don't understand that. Okay, it's okay. And so the next question is that if we know this, and so we need to use the math. And so the general diagram to create your control system theory basis in here, we have the mechatronic, and so just like said the Freya, it's a combination of some things, the mechanic and electronic, right? And so this mechanic should be given in the form of the what? Mathematical equations, right? And so this electronic also a mathematical equations, or we can add the electric or hydraulic system just like that. And so if we combine these two mathematical forms, for example, the mechanic systems must be obeyed with the what? Newton's law, right? F equal m times a, or x dot, right? In the electronic, we need to follow the what? The Kirchhoff, right? And so, but if you are a mechatronic engineer, you should combine it, mechanic part and the electronic part, or the electric part, in a one form, which is called to the what? System dynamic. And so, Sude, what is system dynamic? Just tell me. Yes. Be free to speak. Make it nonsense. Sentences, words. Just tell me. Just now, anyone can define the system dynamic in the perspective of the mechatronic engineer. Anyone? Yes? Systems, but in terms of the what? The mechanic, electronic, and electric, right? But if we are engineer, and so we need to use the mathematical formulation of the mechanics, or the electronic, or the electric. Otherwise, we are users, right? Anyone can say that it's a combination of the mechanical or electric, but you are an engineer, Freya, right? What's the meaning of the Freya? Shiny days. It's in Turkish? Parlak güneş demek. Işıltılı. So, this is a mechatronic, but we need to interpret this mechatronic as an equation, or we just say it equation of motion. In Turkish, hareket denklemi. But in electric, we have also equation of motion, but in the electric, flow part is equal to what? Current. This is the same. This is analogical part of these terms, okay? So, in second place, we need to talk about the section 2. I will share these notes through Google Classroom, okay? What is system dynamic? We need to write in detail. So, Freya, we have some definition in here. System dynamic. And so, just tell me which parts creates or consist of the system dynamic. For example, I can say that the one of the part is the mechanic, right? And so the other part, yes, keep going. Bağır, bağır. Bağır gitsin. Ne kadar bağırırsanız. Yes. Automation is not one of them because it's not the main area of these terms. We have mechanic, electronic. No. It's not. Hydraulic. Yes. Girin çocuğum, niye bekliyorsunuz orada? Sıra bakıyorum. Yes. What's your name? You. No, not that. That one. Yes. Huh? Beyza. Beyza. Just tell me. One of the part of the system dynamic. Bilmiyorsam bilmiyorum de. Hocam ben bilmiyorum de. Buraya öğrenmeye geldim de. De ki ben de devam edeyim. Ha? Fluid, but this is included in the hydraulic. Huh? Yes, heat or electromagnetic. Right? In the previous section, section 1, right? This must be written in mathematical form. But how can we do that? In order to represent the mechanical system or system dynamic, we need to use what? Mathematical model, but in terms of what? Which rule should be used in order to represent the mechanic system? Huh? No. Huh? No. Yes. Yes. Which is written by the Newton, right? Okay. The Newton, right? For the electronic or the electric, we need to use or we must obey the rules of the who? Kirchhoff, right? Hydraulic. One of the famous guy in hydraulic with the B, the first letter. Huh? No. Yes, Bernoulli. Very good. For the heat, anyone? No, it's related to fluid dynamics. Fourier, right? Do you know it? Have you heard anything about the Fourier? Have you taken anything about the heating system? Right? Is there a lesson about it? A course? Okay. So, system dynamic is a combination of the what? This system, mechanic, electronic, electric, hydraulic, heat, right? But if we are an engineer, and so we need to write these terms in terms of the what? The sum rules. For the mechanics, the Newton, electronics, or electric, Kirchhoff, fluid, Bernoulli, and the heat related to what? The Fourier, right? Okay. So, for the standard physical forms, must follow this procedure. Okay. Firstly, we need to derive the equation of motion, guys. What is equation of motion? Freya, I know your name. Every question. Okay. What is equation of motion? Mez. Abi hiçbir şey anlamıyorum. Yaşlandım mı acaba? Allah Allah. Mez. Okay. What is the equation of motion? No. Okay. I'm here to do that. The equation of motion is the what? For the mechanical system, mx dot dot. What is the meaning of the x dot dot? Acceleration, right? It's the second derivative of the what? The position with respect to the what? Time. If you want to model anything, and so you need to use it, okay? Or just see that tau I times theta dot dot. Who is Pelin? You? Okay, Pelin. What is theta in here? Just say anything. No. Yes, but it's just kind of the position, but in rotation, right? Okay. And so these are two components of our mechanical. Because in the mechanics, we have two motion, translational and rotational, right? We can either turn or goes forward, right? Very. So, for the electrical rules, voltage L times di dt. What is the meaning of this equation? L times di. What is the L? Inductance, right? I is a current, right? This consists of the what? The whole equation of motion. Equation of motion is the representation of your system dynamic equation, but in a general name, right? If you are using the Newton law, and so this is the also equation of motion. Equation of motion is a general name for this system. If you want to design any mechatronic system, this equation of motion turns into the what? System dynamic, right? Okay. So, this is the first part of your creating the physical forms in mechatronic systems. We need to derive the equation of motion. After that, we need to observe or analyze time response with, first of all, we need to use the transfer function, right? And also state space. Beyza. Nerede Beyza? What is state space? Bilmiyor musun? Olabilir. Sude. Arkadaşlar bilmiyorsanız direkt bilmiyorum deyin, hemen devam edeceğim. Başka birine geçeceğim. What's your name? Ne? Mahmud. Yok olmadı. Tamam olmaz. Okay. Yes. This is related to what? The time response or the time characteristics. If you want to use the transfer function, this is related to the what? Frequency characteristics, right? But how can we create the transfer function? In order to build the transfer function, you need to use or you need to have to what? The equation of motion, right? This follows this procedure, right? This is just kind of x dot ax plus bu, and this is just kind of what? Gs a divided by s plus b, right? Anyone remember that? All dynamics are represented in the one form, and so we can drive this system to everywhere, right? But how can we do that? In the section 3, we need to talk about it. Section 3. What is control theory? Suppose that we have just kind of system. We have the actuator in here, just like this one. And also we have a rod in here. And we have a mass, M. This is a rod. And this is the actuator, right? And this actuator enables us to move this M in the direction of X, right or left, right? Can do that. So, as an engineer, we should give some conditions in here, some purpose, right? Without purpose, you don't need to build this system, Freya, right? Okay, and so we want to move so that 1 meter to mass, for example, to the right. Okay, so we need to activate or actuate the motors. In a simple case, we need to give some electricity or the voltage applied to the actuator, and so the rod goes to what? To the right or the left, right? So, if I am asking about this system, how you can model this system? Just remember the system dynamic lesson. How we can model this system? Yes, so you can help me to write that. Anyone remembers that the block diagram or the transfer function from the system dynamic? In order to represent this dynamic, firstly, you need to decide that this system is the mechanical or electrical or hydraulical or heat. In this case, this system should be represented with the what? Mechanical. Okay. And so, if you want to use the transfer function, we need to write the what? A block diagram, just like this one. And so, we can say that this is the GS. GS is a symbol of the what? The transfer function in here. This GS should represent the what? The dynamics or the equation of motion of the mass, right? And so, what is the output of this GS? Huh? No. Lisa, what's the output of this GS? What's your name? Sajid. Sajid. What's the output? No. YS. Yes. What's the type of this output? If we have the X in here, and so we should generate the XS from this transfer function. And so it's what? It's in the position terms, right? This should be generate the position in the frequency domain. And so, what is the input of this system? We should give the mass something, and this mass goes to the what? The right or left? Yes, force, right? Fs, right? In order to generate this force, which component should be used in the system? Actuator, right? But if you want to design this actuator, and so we need to write another block to generate the what? This force, right? And so I can say that this is the CS. This should be electronic circuit or actuator, right? If we want to move this mass to 0.1 meter to the right, and so we need to give some another input in here. No. We need to give this system the purpose, right? And so, if our system does not know the meter or the reference, it cannot handle to what? It goes to right or left. And so, this should be x ref s, or the reference, right? We should inform this system to what? You must go to 0.1 meter or 1 meter or 2 meter. Otherwise, it cannot decide what to do, right? Okay. So, what's the simplest model for this app in here? How can I model this term, this mass? No. So you need to think about the equation of motion. How can we model this system? Just remember the Newton's law. F is equals to the mx dot, right? And so, if I apply the Laplace transform to this case, and so we have Fs, this is the term, m is a constant, s square xs, right? And so, if I want to write the gs, Fs is input, xs is output, and so I need to obtain this form, right? Right? Okay. 1ms square, right? See? This gs should be equal to the what, Pelin? Okay. Ajit? No. We need to write the gs in here, in the transfer function. Arkadaşlar transfer fonksiyonunu hatırlayan var mı? Artık sormak zorundayım. Ulan zaten bundan yaptım. Bakalım ne biliyorsunuz ne bilmiyorsunuz. Kendi başına transfer fonksiyonu yazabilecek biri var mı? Does anyone can write the transfer function for any system in this class? So, if this is the xs divided by fs should be given in here. This must be equals to what? The gs, right? From this diagram, because the fs times gs must be equal to the xs, right? See? So, this system is equals to the what? This one. We have xref signal. I'm sorry. S, and so we have the input in here, we have the controller or the actuator in here, just like this one. This generates the what? Fs, and so this block must possess with what? The m times s square, and so this generates the xs, right? From the previous sections. And so in S domain, what's the S domain? Yes, frequency domain, right? If you apply the Laplace transform to any equation of motion, and so you will get the S domain, right? Or the transfer function. And so, how can we calculate the XS in here? Anyone remembers that? Freya? Okay. Razi? Sajid? Yes? Fs times? Yeah. And so the xs, just see that this is the gs. What is the input of the gs? Fs, right? But fs is generated from the what? The cs. And so the input of xref times cs creates the fs, right? Okay. And so fs and then 1 ms square times cs times xref s should be given in here. In the final form, we have xs is equals to the what? 1 divided by m square s times cs times ref s, right? This is the what? Input to the output mapping to mass system in order to what? To actuate this system to move right or left, right? Okay. But if you want to move this system to the reference or the desired point in the frequency domain, we need to match or write this condition. This x ref s must be equals to the xs. Just imagine that if the x ref is 1 meter and the x is 1, and so our objective is completed, right? Must be done. But if I choose or shift the x ref is into the what? 0.5 point. And so this xs must going also to the what? To this x reference. And so if I want to control this system or drive this mass to the reference point, we need to supply this condition. X ref s must be equal to the x. How can we do that? No. Xs is the output. Xref is the input. Yes. Or this is the closed loop control. But we have another control. Just see the equation. The equation is simple. Just see that. X is equals to the what? 1 s square times c, right? Times x ref. If you want to what? The x is equals to the x ref, and so yes, if you want to do that, just see that if this is the case, x divided by x ref is 1 s square times c, right? And this must be equals to the what? To the 1. And so how can we equalize to 1 to this system? Just like the, what's your name? Burak. Burak said, if we choose C or design the C, s square. And so, if you combine these terms, x divided by x ref is equals to 1 s square times s square is equals to the what? To the 1. Okay? So, this is the mathematical perspective to design a controller. Because if you want to design the controller system, either using the electronic system, electrical system, or based on the software, we need to calculate in the math first, right? If I choose to s square in here, and so I can design it because I know that the s represents in the time domain to what? What's your name? Reha. Yes. What's the meaning of the s in the time domain? It must be equals to what? The proportional is a constant value, but we have two terms. What? Derivative, integral. What's the meaning of the s? I'm not sure. Okay, Burak? Huh? No, it's not a constant. If you remember the Laplace transformation, if we have an s, this should be derivative. If we 1 over s or 1 divided by s should represent to the what? The integrator. And so I see that I need to use cascade derivatives to design these controls in this case. Okay? This is our objective. Türkçe açıklamamı ister misiniz? Herkes anladı mı? Yani bakın. Şimdi bakın. Bizim çıkışımız var, girişimiz var. Biz bunları bir şekilde birleştirmeliyiz. Yani ikisini aynı yapmalıyız. Bizim elimizde bir sistem var. 1 bölü ms kare. Değil mi? Ben buraya öyle bir kontrolcü tasarlamalıyım ki bu denklemi çarptığımda bu 1'e eşit olsun. Ben eğer c'yi m çarpı s'nin karesine eşitlersem ne olur? Bu 1 olur. Bu kontrolcü tasarımı demektir. Yani siz bunu çarptığınızda bunun sonucu 1'e gidecek. Ms kare ne demek burada? Ms kare S derivatife karşılık geliyor. Demek ki sizin elektronikte de yazılımda 2 kere türev operatörünü alıp kütleyle çarptığınızda burada bir kontrolcü tasarımı yapabildiğinizi söylemeniz lazım. Kontrol teorisi dediğim şey aslında bu arkadaşlar. Anladınız mı? This is called open loop. Open. What is open loop? Or closed loop? Anyone? Yes. We measured some things, right? Position, velocity, acceleration, and feed to the what? To the reference or the computer to evaluate. What are conditions, right? But in the open loop, you don't need to do that. We have an actuator, and so we have a controller, Pelin, and so this controller is run by m times s square in here, and so xref is fed to the what? This controller, and this controller generates the what? The force or voltage. And this voltage or force drive the mechanical system, the mass, right? You understand that? This is the simplest controller design for a given open loop system. But just remember that in order to design this system, we need to use the math, just like this one. If we know the Planck model or the GS or 1 divided by ms squared, and so we can write the mathematical equation for the what? For the controller or the fixing part of this system to generate the force or the proper force or the driving force. Right? Do you understand that? Burayı anladınız mı arkadaşlar? Bakın biz burada serbestiz. We are free to design the controller. But we must sure that x divided by xref must be equal to the 1. Or x is equals to the xref. If that is supplied for this system, and so this is the controller. This is the rule to design the controller. Okay? Yani bizim elimizde bir sistem olacak. Bunu matematiksel olarak bir kere yazacağız. Başka şansımız yok. Matematiksel olarak yazdınız mı? Hemen matematiğin içerisinde manipülasyon yapacaksınız. Denklemi bulacaksınız. Aa, bu denklem varmış. Evet, bu denklemi yapmam için benim ne yapmam lazım? Yazılıma bunu koymam lazım diyorsunuz. Referans sinyali veriyorsunuz. O referans sinyalde ne yapıyor? Bu sistemi istenen yere götürüyor. Just Freya said this is the open loop, right? But we have the closed loop. Beyza, what is the closed loop system? Sacit, var mı cevap? Burak? Hı? What is the closed loop system? System with the feedback, right? Your closed loop system is equal to the what? System with the feedback. Open loop system? No feedback. Yes. We need to define these terms because this is important. This one especially for taking measurements. So we need feedback. In the feedback form, we need to write the plans, just like this one. Plans. And so we generate the XS, right? This plant generates to what? The position, or in mathematical terms, XS. Okay? So, in order to activate this plant, this is a mechanical system. In the mechanical system, we need to feed this plant to what? Huh? Purpose, but yes, F. In order to activate this system, the mechanical system, we need to give the force or torque. Okay? Fs. And after that, in order to generate this Fs, we need to use in real life actuator, right? Motor or something like that. And so, in order to control this actuator, we need to use the driver, electronical driver, right? Or controller, software-based controllers. So, we have the actuator, and so this is the I or Vs, current or the voltage should be applied to this system, and the electronic driver must be controlled with a control signal, right? Maybe this is the zeta s, but how can we calculate the zeta s? In the feedback, we give the xref s in here, but we have the comparison, or we compare these two signals, the reference signal and the measured signal. In order to what? In order to create the error. In this case, we want to minimize this error. If the error is 0, and then this means that we can drive the system everywhere that we want, right? Because the error, in that case, ES, if ES is going to 0, then xref must be equals to the x, right? See? Yani arkadaşlar, eğer ki biz bu geri bildirimi alırsak, ölçümü alırsak mesela burada, biz bunu aldığımızda hep ne yapacağız? Hep hatayı sıfırlamaya çalışacağız. Hata hep sıfırsa ne demek bu? Demek ki x ref neredeyse x de oradadır demek. Değil mi? O zaman ben bu hatayı sıfırlamak için ne yapacağım? Kontrolcü tasarlayacağım. Bu kontrolcü ne sayayım? Denklemlerle tasarlayacağım. If you want to equalize these terms, just remember the what time response, t, x. For example, we have these terms just like this one. This is the x ref, and so if we have the proper design in here, this actuator generates this kind of time response, just like this one. We push the what? The force at the beginning, and so the x ref is smaller than the x, and so we generate what? The minus force or the negative force, and positive and negative and positive, and so this kind of oscillation happens at this moment. Okay, this generates just like time response of these terms. Et is going to what? To 0. Yani bakın, bizim bir sistemimiz var, şartımız var. Eğitimimizle kuvvet ürettik, bunu yaparken voltajı aldık, voltajı aldıktan sonra Eylem kuvvet. O zaman ne yapmış oluyoruz işte? Kontrol. En basit anlamıyla aslında kontrol etmek bu anlama geliyor arkadaşlar. Soru olan var mı? Okay. Let's take a break for 10 minutes. After that, we will continue.